Right. Good morning. Good morning to all, dear friends. In last session, I'm clearly introduced how to chase all BDR and SFG questions in a 20 seconds. Hope you enjoyed a lot. And today we'll discuss how to chase the same manner, like a quick manner, polar plot questions. Right? So guys, please try to remember. Before going to applying the shortcut methods in where it is BDR and SFG, I introduced the 4 models. If you're understanding that 4 models well, check once. I think you know well. Every question you feel like very easy or not. Like that, here also, I would like to introduce one big table. If you're understanding that table well, guys, once again I would like to repeat. If you're understanding that table well, whatever the question from the polar plot and Nyquist plot, you feel like very easy. Right? Clear? So first, I would like to design the table, and further we'll go some more questions. Then I have some good clarity about my intention. Right? One minute. Right? So guys, carefully listen. See once carefully. So here I would like to classify like a 2 cases. No parameters at origin, no parameters at origin, and next one is parameters at origin. Parameters at origin. I hope you know well what is the meaning of parameters. In our whole control system analysis, system parameters means what? Either poles or zeros. Guys, carefully listen. Carefully listen. Here parameters means either poles or zeros. Either poles or zeros. Are you clear? That means if any one pole is lying at origin, what happened? If no pole is lying at origin, what happened? If any zero is lying at origin, what happened? If no zero is lying at origin, what happened? That is my intention. So complete analysis, I would like to classify like 2 categories. One is if any parameter is lying at origin, otherwise no parameter is lying at origin. For example, s plus 1 by s plus 2. Check once. No pole at origin, no zero at origin. S plus 1 by s into s plus 2. Check once. 1 pole at origin. Otherwise, s into s plus 1 by s plus 2. 1 zero at origin. Are you clear? Right? So this is the main view. No parameter at origin and parameter at origin. I hope you understood well. Right? And one more thing is, in our complete analysis, wherever I'm using the capital P, that is indicating number of poles. Wherever I'm using the capital Z, that is indicating number of zeros. Number of zeros. So capital P is indicating like what? Number of poles, and capital Z is indicating like what? Number of zeros. So once again, I would like to tell you clearly, guys, here I am not discussing the complete depth analysis of the polar plot, just I am introducing how to get the answer in a quick manner. That means for shortcuts only I am introducing here. If you want more knowledge about the polar plot and Nyquist plot, please join in where it is Engineers Hub, then you have some good clarity about my view, right? So guys, so wherever I'm using the capital P, that is indicating like what number of poles, and the capital Z, that is indicating like what number of zeros. For example, guys, listen carefully. I'm taking three different transfer functions like s plus 1 by s plus 2, s plus 1 by s into s plus 2, s into s plus 1 by s plus 2. Here I'm taking like a three different categories, guys. Once again, I would like to repeat. S plus 1 by s plus 2, one pole and one zero. That means number of poles and number of zeros are equal. S plus 1 by s into s plus 2, check once, two poles, one zero. That means number of poles are dominating the number of zeros. And next case is s into s plus 1 by s plus 2, two zeros and one pole. That means number of zeros are dominating the number of poles. So that means what can you understanding about here? Here three cases will be existing. Maybe poles are dominating, or maybe zeros are dominating, otherwise number of poles are equal to number of zeros. I would like to take all the three cases. Guys, carefully listen. First case is maybe number of poles are dominating number of zeros. And the second case is maybe number of zeros are dominating number of poles. And third case is number of poles are equal to what? Number of zeros. Total three categories, guys. Ready? Right? So now see carefully, here total how many cases will be existing? 1, 2, 3, 4, 5, 6. If you know this all 6 possibilities, then whatever the question from the polar plot and Nyquist plot, you feel like what very easy. Sir, what is that internal matter? Nothing is there, guys. So take any plot, either root locus plot or polar plot or Nyquist plot. First, we need to recognizing where it is started and where it is terminating. Say yes or no. That means, so what here we need to calculate starting plot position and ending plot position. If you know the starting plot position and ending plot position, then it's very clear or not. Are you clear? So the same thing I would like to introduce here, guys. Carefully listen. Carefully listen. See, starting plot position, ending plot position. Again, starting plot position, ending, one minute. Ending plot position. Are you clear? Right? I think you know polar plot and Nyquist plot both are depends on what magnitude and phase, right? Are you clear? Right? So see, starting point magnitude, starting point phase, and ending point magnitude, ending point phase, how to calculate in a quick manner, now I will introduce. If you know that one, then the designing is very easy. Are you clear? So guys, carefully listen. Carefully listen. So see, how to calculate the, if number of poles are dominating the number of zeros, how to calculate the starting point magnitude and the starting point phase. Like that, ending point magnitude and ending point phase. Like that here also, if zeros are dominating the poles, how to calculate the starting point magnitude and starting point phase. And here also, how to calculate the starting point magnitude and phase, like for all that cases, magnitude and phase. If you know that one, then the designing is very easy. Magnitude and phase, magnitude, phase, magnitude, phase, right? So here also same, magnitude and phase. Here also same, magnitude and phase, magnitude and phase, magnitude and phase. If you know all that cases, then the designing is very easy. So how to fulfill that table in a quick manner, now I would like to introduce. Guys, carefully listen. Carefully listen. I think you know, you have some knowledge about the control system. Guys, carefully listen. Each pole generating maximum phase equals to how much? Minus 90. And each zero is generating maximum phase equals to how much? Plus 90. So remember carefully, each pole generating maximum phase equals to how much? Minus 90. Like that, each zero generating maximum phase is plus 90. Are you clear? For example, one pole minus 90, two poles, 2 into minus 90, n poles, n into minus 90, 1 0 plus 90, 2 zeros, 2 into plus 90, n zeros, n into plus 90. For example, 10 zeros are present, no problem, 10 into 90, 900 degrees phase. That is the maximum. Are you clear? Otherwise, one system contains one pole and two zeros. One pole and two zeros. So, one pole means what? 1 into minus 90. Two poles means what? 2 into plus 90. Otherwise, one pole and one zero phase gets cancelled. 90 minus 90 gets cancelled. Remaining is what? 1 0. So, that means overall phase equals to plus 90. Are you clear? So, please try to remember this logics. Why? Because complete picture, complete cinema depends on these logics only. And guys, carefully listen. One pole means what? Minus 90. Two poles means what? Minus 180. Three poles means what? Minus 270. That means check once. This direction looks like how it is clockwise direction or not. Minus 90, minus 180, minus 270, minus 360 like that. This is indicating like what? Clockwise direction or not. So that means what can you understanding about here? If poles are dominating, damn sure the plot direction is looks like what? Clockwise only. Am I right or wrong? So check once guys. See. See, 0, minus 90, minus 180, minus 270, that means this is looks like what? Clockwise direction, and see once, 0, plus 90, and plus 180, and plus 270, and like that, it is indicating like what? Anti-clockwise direction. So here, one more small hint is, guys, carefully listen. Whatever the given transfer function, if poles are dominating, damn sure the plot direction is a clockwise. If zeros are dominating, damn sure the plot direction is anti-clockwise. For example, s plus 1 by s into s plus 2. Number of poles are 2, number of zeros is 1. That means what? Poles are dominating. That resultant plot is must be clockwise direction. For example, s into s plus 2 whole square by s plus 1. S into s plus 2 whole square by s plus 1. That means what? 3 zeros and 1 pole. 3 zeros and 1 pole. Which one is dominating here? Zeros are dominating. So zeros are dominating means what? There is no doubt the resultant plot is must be like what? Anti-clockwise direction. So this is the way to what? Recognize the direction. If, see guys, carefully listen. If poles are dominating, there is no doubt the resultant direction is what? Clockwise direction. If zeros are dominating, there is no doubt the resultant direction is what? Anti-clockwise direction. Are you clear? If poles are dominating, clockwise direction. If zeros are dominating, anti-clockwise direction. Okay, cool. By default, if number of poles are equals to number of zeros, then what? Like s plus 1 by s plus 2. Otherwise, s plus 1 into s plus 2 by s plus 3 into s plus 4. 2 poles, 2 zeros, 1 pole and 1 zero. Like that. Number of poles are equals to number of zeros. Then what? Guys, carefully listen. If number of poles are equals to number of zeros, the recognition, see, the way of recognition is different approachment is there. Generally, if poles are dominating, the recognition is very simple. It's a clockwise direction. If zeros are dominating, the recognition is very easy. It's a what? Anti-clockwise direction. By default, if both are equal, guys, by default, if both are equal, so how to recognize the direction of that plot? It's a very, very simple. Guys, this case, this case, how to get the direction? How to get the direction? It's a very simple. See once. Listen. Listen. So this is one S-plane and this is one S-plane. Real axis and imaginary axis and real axis and imaginary axis. Guys, carefully listen. Carefully listen. See, in one case, pole is nearer to the imaginary axis and 0 is far from the imaginary axis. In another case, 0 is nearer to the imaginary axis and pole is far from the imaginary axis. Simple example. S plus 10 by S plus 1. Pole at where it is? Minus 1. Pole at where it is? Minus 1. 0 at where it is? Minus 10. So that means this case or not? S plus 10 by S plus 1. Reverse. S plus 1 by S plus 10. Now pole at where it is? Minus 10. And 0 at where it is? Minus 1. I hope you understood well. Sir, why you are discussing about these two cases? Guys, carefully listen. So this will be decides the direction. If pole is nearer to the imaginary axis, guys, listen carefully. If pole is nearer to the imaginary axis, 0 is far from the imaginary axis, there is no doubt the direction is a clockwise. Ulta, if 0 is nearer to the imaginary axis and pole is far from the imaginary axis, there is no doubt the resultant is what? Anti-clockwise. Once again, please try to recall this concept well. Otherwise, you feel like very confusion. Guys, carefully listen. Whatever the given transfer function, you are the masters how to recognizing the poles and zeros. It's not a big issue. If poles are dominating, it's a very simple case. It's a clockwise direction. If zeros are dominating, there is no doubt it's anti-clockwise direction. By default, if number of poles are equals to number of zeros, then you go to this analysis. Observe that pole position, observe that zero position. If pole is nearer to the imaginary axis and 0 is far from the imaginary axis, clockwise. Otherwise, anti-clockwise. Now, you have the crystal clarity about the direction. Why? Because these are the maximum cases, right? Are you clear? Now, there is no confusion regarding what? Direction. Direction, you are well. Are you clear? Right? So, up to you have some good clarity about my view or not. Next, how to calculate the, if poles are dominating, how to calculate the starting point magnitude and phase, ending point magnitude and phase at no parameters at origin. These all cases I will introduce well. So one by one, I would like to introduce. So please keep on look well. So I would like to rub this one because this is the useless right now. Clear? So guys, carefully see once. Carefully see once. It's a very important. Very important. Guys, if poles are dominating at any moment, either parameters at origin or no parameters at origin, it's not a matter. If poles are dominating, always the plot is terminating at origin. Once again, I would like to repeat this statement. Guys, carefully listen. If poles are dominating, whether no parameters at origin or parameters at origin, it's not a matter. It's not a matter. Always the plot is terminating at origin. So what is the magnitude of origin? 0, right? What is the magnitude of origin is 0, right? So guys, carefully listen. If poles are dominating, ending plot magnitude is always 0. Ending point magnitude is always 0. Whether the parameters at origin or no parameters at origin, it's not a matter. It's not a matter. Are you clear? I hope you understood well. I hope you understood well. Guys, once again I would like to repeat. If poles are dominating, plot is always terminating at origin only. Whatever the crucial situation, whether no parameters at origin or parameters at origin, it's not a matter. Next, what is the quite opposite analysis of 0 according to our control system? Infinite. Are you clear? Guys, carefully listen. That is the second case. If zeros are dominating, listen carefully. If zeros are dominating, there is no doubt. Ending plot magnitude is always terminating at where it is infinite. Infinite. So, it's infinite. It's a infinite. It's a infinite. It's a fixed. Are you clear? I hope you understood well. If poles are dominating, ending plot magnitude is always terminating at where it is origin. if zeros are dominating, always plot is terminating at where it is infinite. It's a very clear. By default, if both are same. By default, if both are same, no doubt, no doubt. Those are always terminating at where it is 1. Those are always terminating at where it is 1. If number of poles are equals to number of zeros, ending plot magnitude is terminating at where it is 1. If number of poles are dominating number of zeros, terminating at where it is origin, otherwise terminating at where it is infinite. You have the clear view or not? These are always common, irrespective of the transfer function. Are you clear? So now check once. 1, 2, 3, 4, 5, 6 are done. No need paper and pen. No need the big analysis. Are you clear? Right? I will show you some questions. Then you have some more clarity. Wait some bit of time. Right? So once the table is completely filled, then we'll go to what? That analysis. Clear analysis. Right? 1 minute carefully listen, guys. So ending magnitude is done. Ending plot magnitude is done. What about the starting point magnitude? Guys, ending point magnitude is common for both two cases, right? Whether the no parameters at origin or parameters at origin, it's not a matter. It's not a matter. But starting point will be changes. How it is changes? Guys, carefully listen. This is very simple. First, I'm discussing about no parameters at origin. No parameters at origin. I think you have some good clarity. No parameters at origin means simple example is s plus 1 by s plus 2, like this one. Right? This is one small example. And parameters at origin means what is the small example is s plus 1 by s plus 1 by s into s plus 2. Otherwise, s into s plus 1 by s into s plus 2. Your wish. It's not a big issue. Those are the simple examples. Right? Guys, carefully listen. Carefully listen. Listen. See, if no parameters at origin, magnitude, starting point magnitude calculation is very easy. Sir, how to calculate? Simple. In place of s, replace 0. That's enough. Are you clear? So guys, there is no space. That's why I'm using the symbol like this one. See, the meaning of that symbol is, see, in place of s, replace with 0. Replace with 0. Replace with 0. For example, this is only the example. What is the starting point magnitude? In place of s, replace 0. Then whatever the answer is, 1 by 2. Starting point magnitude equals to 1 by 2. That's enough. So this logic is a common, guys, this logic is a common for this case and this case and this case. Are you clear? Whether the poles are dominating 0, it's not a matter. Whether the zeros are dominating the poles, it's not a matter. If poles are equals to 0, it's not a matter. It's not a matter. Are you clear? So whatever the case, it's not a matter. Always in place of s, replace with 0. For example, what I'm taking that example is for this one, right? Number of poles are equals to number of zeros. 1 pole and 1 zero. Number of poles are equals to number of zeros. Actually, this is the example, right? Clear? So how to calculate the starting point magnitude? So in place of s, replace 0. That's enough. Magnitude equals to 1 by 2. Ending point magnitude is always fixed. How much? 1. So I hope you understood how to fill these 3 positions. Are you clear? Right? And next, come to here, guys. Come to here. Guys, listen carefully. Listen carefully. See, if any parameter at origin, like, guys, it's very important. Listen. Listen. See, even one pole at origin, like s plus 1 by s into s plus 2 or s plus 1 by s square into s plus 2, whatever it is, even one pole at origin, there is no doubt starting point magnitude is always infinity and ending point magnitude is always 0. Guys, what can you understanding about here? Check once carefully. Already you know it. Ending point magnitude equals to how much? 0. Then starting point magnitude equals to how much? Infinite. It's a fixed. Even one pole at origin, starting point magnitude is always infinite. Which infinite position, how to chase that one, I would like to discuss you some bit of time. Wait some bit of time. Are you clear? But I hope you understood well. Even one pole at origin, guys, even one pole at origin, starting point magnitude is always fixed like infinite, and ending point magnitude is always fixed like what, 0. No need to go to regular method. Right? Next, even 1 0 at origin, opposite case, even 1 0 at origin, no more talk, starting point magnitude is reverse. Here infinite means what? Here 0, and the ending point magnitude is already you know it. How much? Infinite. Ending point magnitude equals to how much? Infinite. Infinite reverse, guys. So what can you understanding about here? It's a 0. Right? Even one pole at origin. So the plot is coming from the infinite and going to terminating at where it is 0. Even 1 0 at origin, guys. Even 1 0 at origin. So starting point of the plot, that means what the plot is started at origin and terminating at where it is infinite position. Right? So next this case, guys, carefully listen. So this case is very clear, but this case bit of confusion is there. What is the confusion now? So here again two possibilities. Here only two possibilities. One possibility is, listen, one possibility is if pole at origin, another possibility is if 0 at origin. If 0 at origin. For example, s plus 2 whole square by s into s plus 1. Once again I will repeat. S plus 2 whole square by s into s plus 1. Check once. Here also 2 poles and 2 zeros. But one pole is lying at where it is origin. Reverse. S into s plus 1 by s plus 2 whole square. Now 1 0 at origin or not? On that situation, this will be come to the picture. Are you clear? So if pole is, guys, if pole is lying at origin, same concept, starting point magnitude equals to how much? Starting point magnitude equals to how much? Infinite. And if 0 is 0. In both two cases, this is terminating at 1 only. Now check once, all the magnitude positions are done. Got the clear view or not? Are you clear? If you want individual examples, I will give you the examples after completing what, otherwise I will do one thing. So for this case, I will take one example. For this case, I will take one example. For this case, I will take one example. Then you have some more good clarity. So see once. So listen, for example, I'm assuming like what this is a case 1. Guys, what is the case 1 example? Transfer function g of s equals to, guys, carefully listen, must be poles are dominating and no parameters at origin, like how it is s plus 2 by s into s plus 1. Sorry. S plus 2 by s plus 1 into s plus 3. Are you clear? Check once. No parameters at origin, no pole at origin, no 0 at origin, and number of poles are how many? 2, and number of zeros are equals to 1. That means what, poles are dominating, zeros are not. So see, for first case, this is the example. This is only one example. You have a lot of examples. And see, this is the second case. Otherwise, I will take this case. This is the second case. For second case, what is the example? Second case, see once. G of s equals to s plus 2 into s plus 3 by s plus 1. Check once. Here number of zeros are what? 2, and number of poles are what? 1. Now zeros are dominating, the poles are not. This case. Are you clear? So this is a case number 3. So case number 3 example is g of s equals to s plus 10 by s plus 1. Check once. Here number of poles are equals to how many? 1. Number of zeros are equals to how many? 1. So number of poles are equals to number of zeros or not? right? Like that. Fourth case, what is the example? Fourth case, what is the example? See once. Fourth case example is g of s equals to s plus 2 by s into s plus 1. Check once. Here also number of poles are 2, but one pole at where it is? Origin. Parameters at origin. Pole or 0, your wish. Right? And case number 5, example is g of, examples only, g of s equals to s into s plus 2 by s plus 1. Are you clear? And last case, sixth case. This case, g of s equals to s plus 2 whole square by s into s plus 1. I hope you understood well what are the relevant examples. Are you clear? Right? Now I would like to analyze phase cases. Once the phase case is done, then we'll go with what how to draw the plot for this all the cases. I will show you very clearly. Right? Once you're understanding this table well, guys, whatever the question, the designing plot is a very simple. Hardly 10 seconds or 20 seconds is more enough to draw the plot. So transfer function to plot also very easy, and plot to transfer function also very easy. Both are very easy. Okay, we'll go with what one by one to phasing what phase. First, I would like to discuss all end plot phase. That means this one. I will discuss the phase related to what? End plot. Why? Because for all the cases, only one way. What is the way now? Guys, carefully listen. Whatever the situation, actually here I am discussing like what 6 different situations, right? In all 6 situations, listen guys carefully. In all 6 situations, the final phase calculation is only one way. What is that way now? Total parameters phase. I'm using this symbol. I'm using this symbol. Are you clear? The meaning of that symbol is total parameters phase. Total parameters phase. So what is the meaning of total parameters phase? Simple guys. Already you know individual pole phase equals to minus 90. Individual zero phase equals to plus 90. That thing you have some good clarity. For example, I want to calculate this overall phase. That means what? Total phase. I want to calculate this first case, total phase I want to calculate. It's a very simple. How many number of poles are here? 2 poles. How many number of zeros are here? 1 zero. So 1 into plus 90 plus 2 into minus 90. Otherwise, one zero phase and one pole phase gets cancelled. One zero phase and one pole phase gets cancelled. Remaining how many number of poles? Only one pole. One pole means what is the maximum phase? Minus 90. So there is no doubt. So first one is terminating maximum phase at where it is minus 90. Got the clear view or not? For example, I want to calculate this overall phase. Case number 5. That means for example number 5, phase I want to calculate. Simple. How many number of zeros are here? 2 zeros. How many number of poles are here? 1 pole. 2 zeros and 1 pole. 1 pole and 1 zero gets cancelled. Still how many number of zeros are here? 1 zero. That means what is the maximum phase? Plus 90. For example, one system contains 4 poles and 2 zeros. Then 2 zeros and 2 poles gets cancelled, and still how many number of poles are there? 2 poles. That means what? 2 into minus 90 minus 180, that is the overall phase, that is the total phase. That is the end plot phase. Are you clear? So that is the common for what? All. That is the common for what? All. For example, see here, this case, number of poles are equals to number of zeros. Number of poles are equals to number of zeros means what? Poles phase and zeros phase gets cancelled. This phase is always 0. This phase also same, always 0. Are you clear? For example, check once. 3. 1 pole and 1 zero. Phase gets cancelled. What is the remaining phase? Is 0 na? I hope you have some good clarity. Are you clear? Are you confident or not? How to get the final phase for about all the cases? These are the maximum cases, guys. Are you clear? Now we'll move to where it is initial phase. That means what? Starting point phase. Starting point plot phase. Are you clear how to get that one? That is also very easy, guys. Very easy. Guys, carefully listen. Carefully listen. It's a very easy. If no parameters at origin, listen. If no parameters at origin, no more talk. Whatever the case, either poles are dominating zeros or zeros are dominating poles or number of poles are equals to number of zeros or whatever the case, starting point phase is always 0 degrees. This is always 0 degrees. This is always 0 degrees. It's a fixed, guys. Always 0 degrees. Starting point phase is always 0 degrees. Got the clarity or not? Next, we need to discuss about these three. Then the table will be completed. What about that one? Guys, I'm using this symbol. Are you clear? I'm using this symbol. What is the meaning of that symbol? What is the meaning of that symbol? Guys, carefully listen. The meaning of that symbol is number of parameters at origin phase. Number of parameters at origin phase. Origin phase. Sir, what is the meaning of this one is? Nothing, guys. Nothing. It's very simple. For example, see, take fourth case or fifth case. What is the fourth case relevant example is? This is the relevant example, right? This is the relevant example, right? So what is the initial phase? Initial phase. How many, see, what is the meaning of this dollar is number of parameters at origin. How many number of parameters at origin? One parameter, one pole. That means what is the initial phase is minus 90. For example, here S square, initial phase is minus 180. Here S cube, initial phase is minus 270. Here S power 4, initial case is minus 360. Like that one. Are you clear? For example, take this case. Take this case, fifth one. What is the fifth one relevant example is? This is the relevant example, right? How many number of parameters at origin? Here also 1. That means 1 0 at origin. 1 0 at origin means what? Plus 90. S square, 2 into plus 90. S cube, 3 into plus 90. 4 into plus 90. Like that, n into plus 90. That's enough. Got the clarity or not? So if you're understanding this table well, then whatever the question, the designing is very easy. I will show you some designs, then I have some clarity about my intention. Are you clear? Ready? Clear? So see carefully. I'm taking the first question, first example. G of S equals to S plus 2 by S plus 1 into S plus 3. G of S equals to, first one is G of S equals to S plus 2 by S plus 1 into S plus 3. S plus 3. Are you clear? So how to design the polar plot in a quick manner with using the table. Ready? So guys, see, one by one, step by step, I would like to introduce. So please listen carefully. You feel like what very easy. Ready? See carefully. Listen. So I'm taking S plane. Ready? Already you know it. This is what? Real axis. And that is what? Imaginary axis. Are you clear? It's not a matter. And guys, carefully listen. One by one we'll discuss. Listen. First tell me, how many number of poles are here? Check once. Number of poles are 2 and number of zeros are 1. There is no doubt here number of poles are dominating number of zeros. So go with the table. So see which one is this one. Number of poles are dominating number of zeros, and carefully observe it, no parameters at origin. no parameters at origin, no parameters at origin, no parameters at origin, and number of poles are dominating number of zeros. That means for this case, this case. So what is the starting point magnitude and phase, what is the ending point magnitude and phase, we'll discuss. That's enough. It's a very simple, guys. See carefully. So here, what is the starting point magnitude and phase? What is the starting point magnitude and phase, and what is the ending point magnitude and phase? Once you are practicing 3 or 4 questions, no need to write like this one. Directly you are able to draw the diagram directly. Are you clear? Right? So what is the starting point magnitude and phase, ending point magnitude and phase? Go with the table, guys. Go with the table. So this is the case, right? What is the starting point magnitude? $. So the check once. What is the meaning of this one is, in place of yes, replace with 0. In place of yes, replace with 0 in given transfer function. So guys, carefully listen. In place of yes, replace with 0, and here 0, and here 0, and here 0. Check once. This is the 0, this is the 0, this is the 0. What is the remaining is 2/3. So starting point magnitude is 2/3. There is no doubt. Starting point magnitude equals to how much? 2/3. So guys, carefully listen. See, this is a magnitude equals to 0. Why? Because it's origin. This is a magnitude equals to 0, and like 0.1, 0.2, like that. Here somewhere magnitude equals to 2/3. Carefully observe it. This is the starting point magnitude. Sir, why you are taking here only? It's a very simple. It's a very simple. I think you know. Which is contains how much degrees phase? 0 degrees phase. So what about this one is 0 degrees, na? It's a 0. It's a -90. It's a -180. It's a -180. It's a -270. It's a -360. I hope you know it. Are you clear? Now check once. So starting point phase is 0 degrees. Starting point phase is 0 degrees, and magnitude equals to how much? 2/3. That means this is the starting point of the plot. This is the starting point of the plot. What about the ending point? Go with the table. Go with the table. Ending point is always terminating at origin. Guys, ending point is always terminating at origin. Yes, always it is terminating at where it is origin. Okay. Are you clear? And what about the phase? And guys, carefully listen. Check the table. What about the phase? Phase is check once. What is the meaning of this one is total parameters phase. What is the meaning of that one is total parameters phase. So what are the total parameters? Check once. 1 0 and 1 pole phase gets cancelled. What is the remaining poles? Only 1 pole. That means 1 pole maximum phase equals to how much? -90. It's a -90. There is no doubt. Before -90, it is reaches to where it is origin. See, it is starting at 0 degrees phase, and before -90, it reaches to where it is origin. This is the ending point position. This is the ending point position. How to draw the plot? Already you know it. If number of poles are dominating number of zeros, this is looks like what? Clockwise direction, right? Clockwise direction, right? Then check it carefully. Check it carefully. Clockwise direction, na? So see once. See, this is the anti-clockwise direction, and what about this one is clockwise direction. Done. Answer done. Simple. I will take one more example based on the same case, then you have some more clarity about my intention. Are you clear? Same case I will take, same case. G of S equals to S plus 1 into S plus 7 into S plus 2 by S plus 1 whole square into S plus 3. S plus 3. I am taking this example. Right? So how to design polar plot? How to design polar plot? So guys, first your step is recognize it. That is what? Which case? Recognize it. That is which case? So which case that is? First you recognize it. Same case, right? Case number 1, right? Are you clear? And now see carefully. How many number of poles are here? How many number of poles are here? Check once. Number of poles are 3. And number of zeros are 2. Are you clear? Where it is present, it's not a matter. At present at -3 now, -7 now, -5, it's not a matter. Are you clear? And guys, carefully observe it. Number of poles are dominating number of zeros. So once you're recognizing that point, you know to go with what? Step by step, step by step, step by step. So what is that steps? Guys, carefully listen. Number of poles are dominating number of zeros means one point is very clear. One point is very clear. What is that point is? What is that point is? The plot is looks like a clockwise direction. There is no doubt. The plot is looks like what? A clockwise direction. So clockwise direction means how to take the phases 0 degrees and -90 and -180 and -270 and -360. Are you clear? Right? Got the clarity or not? So this is the second step. And the third step is, guys, carefully listen. Need to identify the starting point magnitude and phase, ending point magnitude and phase. No need to go with the table also. No need to go with the table also. Simple logic. Poles are dominating. Always it is terminating at where it is. Poles are dominating. Always it is terminating at where it is. Magnitude equals to 0. This is the ending point magnitude. There is no doubt. Guys, carefully observe it. Any parameter at origin? No, no parameter at origin. No parameter at origin means how to recognizing the starting point magnitude is in place of S, replace 0. In place of S, replace 0. In place of S, replace 0. Replace 0. Replace 0. Now 7 into 2, 14. 14 by 3. So starting point magnitude is 14 by 3. Starting point magnitude is 14 by 3. So this is the starting point and this is the ending point. And already you know it. No parameters at origin means starting phase is always 0. How to calculate the ending point phase? How to calculate the ending point phase, which is depends on what total parameters phase. What are the total parameters phase? Guys, carefully listen. 2 zeros and 2 poles gets cancelled. What is the remaining pole is? 1. Are you clear? What is the remaining pole is? 1. So 1 maximum phase equals to how much? -90. So before -90, it reaches to where it is? Origin. Like this one. That's done. Are you clear? Ready? So I will take one more example, then you have some more clarity. Some more clarity you have. See, first case only I will explain with the different examples. From second case onwards, I will take only one example. Ready? So guys, carefully see once. G of s equals to 1 by s plus 2. G of s equals to s plus 1 by s plus 2 whole square. S plus 7 by s plus 2 whole square into s plus 1 whole square. S plus 1 whole square. How to draw the plot in a quick manner? It's a very simple. Very simple, guys. See once. Very simple. First to observe carefully. Poles are dominating or zeros are dominating. In both two cases, poles are dominating. That means 0 and -90 and -180 and -270 and -360. Here also same. 0 and -90 and -180 and -270 and -360. Are you clear? This is the first step. Why? Because must and should, it's a clockwise direction, right? Am I right or wrong? Clear? And next, guys, carefully listen. And no parameters at origin. And poles are dominating. That means it is always terminating at where it is origin. It is always terminating at where it is origin. So there is no doubt. Ending point magnitude is at where it is origin. And here also ending point magnitude is at where it is origin. So ending point is very clear. Poles are dominating. Are you clear? Right? And what about the starting point magnitude? In place of s, replace with 0. In place of s, replace with 0. Now tell me what about this one is? Magnitude equals to 1 by 2. Magnitude equals to 1 by 2. And in place of s, replace 0. Then tell me what is the magnitude is? What is the magnitude is? So 7 by 4. 7 by 4. It's a starting point magnitude. If no parameters at origin means it is always starting with what? 0 degrees phase with some finite magnitude. 0 degrees phase, some finite magnitude. 0 degrees phase, some finite magnitude. Terminating at where it is origin with how much phase? So there is, guys, carefully listen. There is no doubt it's a clockwise. There is no doubt it's a clockwise. But here my question is, see, there is no doubt it's a clockwise. But here my question is, so see once, it is terminating like this one, or like this one, or like this one, or like this one. Here also, it is terminating like this one, or like this one, or like this one, or like this one. That is decided by what? End pointing phase. That is decided by what? End pointing phase. Are you clear? So, what is the end pointing phase? What is the maximum number of parameters are here? Only one pole. That means what? That is the maximum phase. What is the maximum phase here? Minus 90. It is terminating like this one. That's done. Come to here. Come to here. 1, 0 and one pole. Any one pole phase gets cancelled. Remaining how many number of poles? 3 poles. Remaining how many number of poles? 3 poles. 3 poles means what is the maximum phase equals to? Minus 270. That means before minus 270 it is terminating at origin. See once. Before minus 270 it is terminating at where it is? Origin. That's done. Simple. Are you clear? This is the way to what chase. If you are understanding the table well, then whatever it is, approachment is very, very easy. So I will take one more example, then you have some more clarity. Right? So guys, carefully listen. I will take one example relevant to this case. Case number 4. Right? So case number 4, once again check once. Parameters at origin and poles are must be dominating. Poles are must be dominating. I will take one example, then I have some good clarity about my intention. G of S equals to G of S equals to S plus 2 by S plus 2 by S square into S square into S plus 1 whole square. Are you clear? While seeing the question, first you need to recognize 2 points. Poles are dominating or zeros are dominating. That is the first recognition. And second recognition, any parameters at origin or no parameters at origin. So these 2 recognitions are very, 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 very important, guys. Right? Check once. Here poles are dominating. There is no doubt. Why? Because how many number of poles are here? 4. And how many number of zeros are here? 1. So poles are dominating. Poles are dominating means damn sure this is what type of the direction? Clockwise direction. This is what type of the direction? Clockwise direction. So clockwise direction means it's a 0 degrees and it's a minus 90 and it's a minus 180 and it's a minus 270 and it's a minus 360, which indicates like what? Clockwise direction. Which indicates like what? A clockwise direction. Are you clear? Right? And once again, please go with the table, then have some good clarity about my intention. See once. See here the table carefully. See once. This case, right? What is the starting point magnitude equals to infinity and ending point magnitude equals to 0? Guys, see carefully. See once. Starting point magnitude equals to infinity and ending point magnitude equals to 0. See once. Ending point magnitude equals to 0. It's a cluster clarity. Ending point magnitude equals to 0. It's a cluster clarity, no problem. Starting point magnitude equals to how much? Infinity, right? See carefully. This is also infinity. This is also infinity. This is also infinity. This is also infinity. Which infinity I want to choose? Ending point at where it is? Origin. No confusion. It's very clear. It's the ending point position. It's the ending point position. It's very clear. But starting point magnitude equals to infinity, right? It is also infinity. It is also infinity. It is also infinity. It is also infinity. Which infinity I want to choose? So that is decided by what? Starting point phase. That is decided by what? Starting point phase. Guys, carefully see once. What is the starting point phase? See once. This is the starting point phase, right? Number of parameters at origin. Number of parameters at origin. Guys, tell me, how many number of parameters at origin? How many number of parameters at origin? 2. 2 poles. 2 poles means minimum phase equals to how much? Minus 180. There is no doubt. There is no doubt which will be started from where it is minus 180 and magnitude equals to infinity. So this is the starting point. Are you clear? So starting point recognition is your well, and the ending point recognition is your well. Starting point face recognition also your well, and you have only one pending. That pending is ending point face. Sir, what is the need of ending point face? Guys, carefully listen. Already you know it. Poles are dominating means what? Clockwise direction. Poles are dominating means what? Clockwise direction. See once. This is the clockwise direction, right? This is the clockwise direction, right? Clockwise direction, right? So now my question is, which will be terminating to origin like this one, which will be reaching to origin like this one, which will be reaching to origin like this one, which will be reaching to origin like this one. There is a lot of possibilities, right? There is a lot of possibilities, right? Which possibility is correct? How to chase it? That is decided by what? Ending point face. That is decided by what? Ending point face. Already you know well. For all cases, ending point face recognition is same method. What is the method? Is total parameters face. Total parameters face. What is the total parameters face? Guys, see once. 4 poles, 1 0. 1 0, 1 pole gets cancelled. Face gets cancelled. Remaining, how many number of poles are there? 3 poles. So 3 poles, maximum phase equals to how much? Minus 270. So before minus 270, it will be reaches to where it is. It will be reaches to where it is. It will be reaches to where it is. Origin. Then done. Check once. I'm not using any big methods. If you're understanding the table, so within 20 seconds how to get the answer, I hope you understood well. Practice more number of questions, you have some more clarity. In my next video, I would like to show you remaining cases how to chase. At the same time, one special case is there in the polar plot. Check once. Sometimes the plot will be coming like this one. Sometimes the plot will be coming like this one. So that type of cases not chased by the table. So that is a special case. How to chase that special case and remaining cases I would like to introduce, and I will discuss in my next session. Are you clear? Thank you so much for everyone. I hope you understood well the table and related the table. More number of questions we will discuss in the next session, and as usual Nyquist plot, how to develop from polar plot also I will show you very clearly. So you have some more clarity, and just you read the table carefully and practice some questions. In my next sessions, how to chase the tough questions also from the table, I will introduce well. So thank you so much. Take care. Bye.